Hi everyone, and I hope that you're having a good break. As promised, I want to go through and do a video that just kind of gives some hints on some of the problems. What I'm going to be looking at in this video are in the packet, if you were in class, it is the first six problems that you see in that packet. It covers I want to say 5 pages. Three, yeah, the first 5 pages of that packet. This packet consists of 2 sets of free response questions from a previous AP exam, and so this video will cover the first set that is in there. For the first question that you come to, and remember this one and number 2, graphing calculators are allowed, and you would need those to go and do some of these, especially in this case with the first one, where they want to know if the speed of the particle is increasing or decreasing at t equals 5.5. Make sure to give reason for your answer on that one. The thing that you have to remember there is exactly what we talked about in one of the problems that we did in class on Thursday before break. So keep that in mind with what you're doing. Remember, speed does not give direction. Okay, speed is just how fast an object is traveling. It doesn't tell you in which direction it's going. Where velocity and acceleration give you a direction as well. So in order for speed to be increasing, the velocity and acceleration have to have the same sign, SIGN. Okay. Average velocity of the particle from 0 to 6. We have the average value of a function. So just to work with that. Part C is one that I wanted to highlight here, C and D really. What you have to remember in terms of distance versus displacement. The displacement is the net change that you've had from where you started to where you end. Distance is the actual amount that you've traveled. So what you have to remember on here, displacement is the definite integral from A to B of the velocity function, where the distance is the definite integral from A to B of the absolute value of that velocity function. Okay, and the last thing to remember on this one, in that they tell you in part D, they say from 0 to 6, the particle changes direction exactly one time. And they want you to find the position of the particle at that location. So you have a couple different things you have to keep in mind here. You have to find the displacement that is actually distance and displacement on this case for that one, because we're looking at where it changed direction. So the amount of time the distance it traveled and the displacement will be equal up until you change direction. So it's there. But the other thing you have to be aware of is where are you starting out initially. And in this problem, they do tell us that x0 equals 2. So if you want to find location, it's going to be the initial location plus the displacement. So in this case, it's going to be 2 plus whatever that displacement came out to be. In number 2, this is where the pot of T is going to be cooling, and it's modeled by this differentiable function H, and they give you the data up above. What they want you to do, notice you have to be aware of what the table tells you. In this case, the table up here is telling us time in minutes and H in degrees. Now, the first thing is they want us to approximate the rate at which the temperature of T is changing at T equals 3.5. Okay, well, this is something that's been happening. I've noticed happening quite a bit in on the AP exam. That a lot of times they've been going through. There were times when they would say, "Want to know how it's changing at t equals 5," but in this case it's 3.5. So you're just looking at a time that is between the 2 and the 5. So again, this is very similar to a problem that we did in class on Thursday. The part B, you have the trapezoid rule. Okay. Now remember on this one here, if you're looking at the trapezoid rule that we used a lot of time in class, or if you look at one that's on the calculator, you got a little issue with that one in that the ones that we did in class, a lot of times they were with a regular partition, which meant that these values were equally spaced. Well, this is not the case. Okay, so you're going to have to go through and find the area of each individual trapezoid and then add it up to get to answer question B. Explain the meaning of using units, evaluate this definite integral there, and then using correct units, explain the meaning of that expression in the context of the problem. Again, be aware of your units. This is the derivative. H prime is the derivative. And again, we talked in class, we talked about how, doing this stuff symbolically. So you're able to go and evaluate that one. And we did a problem, again, very similar to that one on Thursday as well. And then you want to go through in the next part. You have again your initial temperature. In this case, the initial temperature again is at 100 degrees Celsius as when it's being taken from the oven, and they're telling you how the temperature is changing using this function right down below. And so we want to use that model to come up and determine after 10 minutes how much cooler the biscuits are than the tea. The other thing to remember on this one is that, again, the amount of change that's happened, it's going to involve this. So think about the change that happened is similar to the displacement that has occurred in the previous problems. Now we get to the problems that are being done without a calculator. So from the first two you were allowed to use a calculator. These next four you're not allowed to use a calculator. In this case, in this one here, they want you to write the equation of a line tangent to the graph of f at x equals 1/2. F is the 8x cubed. So you have to put, if you want to find the equation of a line, remember the equation of a line, you need two pieces of information. You need a point and a slope. And so you can plug that into f, and you can get the point. You have to take the derivative of f to identify the slope. But remember, all you need to do in terms of the equation of a line, you don't have to put it in a specific form. I would just leave it in that point slope, y minus y1 equals m times x minus x1. Just plug it into that equation there and use that to get the equation of that line. Part B, find the area of R. Again, remember on this one, you can use, in this case, I think it's probably easier to use, well, not probably, it is easier to use the vertical slicing, even though you could use either one. But remember on that one, it is the top function minus the bottom function, and the expectation is that you could tell that which one is the top and which one is the bottom, just based on the equations that you're given. And then again, part C, notice on there, we're asked to go and write the equation, write a definite integral, an integral expression to find the volume generated when r is rotated about the line y equals 1. What you have to keep in mind up there is y equals 1 is this line right up here. So that's the line. So again, remember when you set that up, it is the volume of that solid. It's going to be outside radius minus the inside radius. So, and it is always in relation to the axis of rotation. Number 5 is a little bit harder. It's a little bit trickier because of all the everything that's happening on this one. The first thing you have in part A, you have to find the equation of a tangent line at t equal, and they say at t equals 0. Well, time equals 0 means that that's at the beginning of 2010, and you are told in the problem that at the beginning of 2010 that there are 1,400 tons of solid waste. So you can use that to help you identify your point, but you still need to find the slope. So you're able to plug that into that is the amount of waste you have. So you can plug that back into your differential equation that we're given here and determine what the slope is and come up with that equation. Next thing you have is they want you to find the second derivative here in terms of W. Well, you got a couple things you have to do. Remember, one of the things that will help you out, this area up here is the derivative that we have. So one thing that can help you out, I think it's really up to you. If you want, you can distribute that 1 over 25. It doesn't have to happen, but you can then find out you can take the derivative of that, and then what you have to remember is that you are taking the derivative with respect to t. So when we take the derivative of w here, it is going to be dw dt. And you also, from there, you know what dw dt is equal to because that's what you're given. So you want to use both of those. And what they want you to do here is you went up in part A, you made an estimate when t was 1/4 of a year for 3 months. You've got to determine whether or not that is part A is an underestimate or overestimate of that solid waste that's there. Now, what you're going to do with that, what I want you to do is I want you to think about a tangent line. Remember, the second derivative tells you concavity, so you really have to think about what's going to be true about a tangent line to a curve when the curve is concave up and a tangent line to a curve when the curve is concave down. What's going to be true about that line? And then use that information to make your determination about what's happening in terms of that approximation, if it's an overestimate or underestimate. Again, at this point in part C, comes out to be a separation. Just separate the variables. And so you can just say dw over w minus 300 equals 1 over 25 dt. And then you're able to go through and do the separation variables and the integration necessary. Don't forget the initial condition that w of 0 equals 1400. So when t is 0, w is 1400. Put that in so that you can find out what c is, what that constant is, whenever it is appropriate or easiest for you to do that. Number 6, again, is a non-calculator problem, and you're asked to go and do some work with a piecewise function. First up, you have to show f is continuous at x equals 0. And remember, last time we talked about, again, on Thursday, we dealt with the whole definition of continuity. You have to remember that in order for a function to be continuous at a particular value c, the limit must exist for that function as x approaches c. The function's value at c must exist, and the function's value has to equal the limit as x approaches c. So if you're going to go through and show continuity, you must show all three of those. Okay, make sure you explain how you can determine that the limit exists, what that function's value is, and how you know it, and then show that they are equal. If it's continuous. Again, and then for part B, we want to express the derivative as a piecewise defined function, and then find the value of x for which f prime of x will equal -3. Well, in terms of the derivative, really to find that derivative, you just take the derivative of each individual piece over its interval, okay? And except, again, at 0, it's not going to work, so you have to drop that off. The other one that you have is set it when it is equal to, determine for which values of x when it's equal to -3. Well, keeping in mind that when I take a look on here, that sine, remember the sine and cosine functions do go between -1 and 1. And so that can help you in terms of eliminating areas where that could be true. Also on this one, don't be afraid of the fact that you might get something that actually is not something you can, a value you can actually calculate without a calculator, where you won't be able to go through and simplify. You may not be able to simplify the expression. So don't be concerned about that as well. And then the average value, remember average value of a function, the average value is 1 over b minus a times the integral from a to b of f of x dx. That in general will give me the average value. Now you have a couple issues on this one because they want to know from -1 to 1. Well, we have in this situation, you'll notice that the functions break at 0. So what you're going to have to do, find the average value of one piece over one part of it for one part of it, and then find the average value of the other piece, and then add those together. So this will conclude the first hint video. My plan is to make another one before the end of the break. Hopefully that gets done. We'll see. But regardless, I hope this has helped at least with these first set of problems. The first 6, which really amounts to the first of the free response AP exams. And you'll find that some of the problems that you have in the second set are going to be, there's going to be some similarities there to what you have in these. So don't be too concerned with that. Just see what you can accomplish with these and see what you can accomplish with the next ones. And like I said, hopefully I will have another video. My plan is to have another video like this for that part, but that will also depend on what time is like and what's happening between now and then. So anyway, I hope your break is going well and that you are feeling at least somewhat productive on some of these. And I will see you on Tuesday after we get back. So today I'm making this. I'm going to post this on Wednesday. So we are within a week of being back together. So again, enjoy yourself, and we'll see you on that Tuesday.